Hello friends, welcome to Civil Engineering Study and Construction channel for today's technical civil engineering video. In this episode, we will learn in detail about hinged staircase, also known as the sawtooth staircase, a very interesting and efficient type of reinforced concrete stair used in modern structure. We will discuss its structural action, design concept, traces and moment behavior, reinforcement detailing and the IS code references that guide its design and construction. So what is sawtooth stair? A hinged stair or sawtooth stair is a reinforced concrete staircase where each flight is supported on beams or landings at the end and the waist slab is cast in a zigzag shape following the profile of the steps. In appearance, it looks like a series of steps supported on a zigzag beam, hence the name sawtooth stair. The main characteristics is that the waist slab is not straight as in conventional slab type stairs, but rather bends at each riser, forming sharp angles. Structural action and support condition of this stair. In the hinged or sawtooth type stair, each inclined portion between the riser behaves somewhat like a cantilever beam, supported alternatively at the riser and tread junction. There are two typical cases of support. Case 1, stair flight supported at both ends on landings or beams, forming simply supported span. And case 2, stair flight fixed or continuous at the ends, which provides additional stiffness and reduces bending moment. In hinged types, the junction between flights and landings behaves like a hinge, allowing rotation and preventing the development of large negative moments at the junction. Thus, the maximum bending moment occurs at midspan of the flight and the shear stress is highest near the support. Now, stress and moment distribution. Let's understand the internal forces in a sawtooth stair. The dead load consists of self weight of the slab and steps, finishes weight and weight of railing. The live load is taken as per IS 875 part 2 1987, usually 3 kN per meter square for residential and 5 kN per meter square for public building. For analysis, each flight is considered as an inclined slab spanning between supports. If the stair is simply supported, the maximum bending moment at midspan is M equal to WL square by 8. If fixed at both ends, then M equal to WL square by 12, where W equal to load per meter run on the slope as kN per meter and L equal to length of the flight along the slope M. Shear force at support equal to V equal to WL by 2. Reinforcement detail and its function. Now let's talk about reinforcement arrangement and its purpose. Main reinforcement provided along the slope of the stair at the bottom of the waist slab because the main tension occurs at the bottom fiber. These bars resist the bending moment due to loads on the tread. Normally 8 mm to 16 mm diameter bars are used, spaced at 100 to 150 mm center depending on span and loading. Minimum reinforcement is as per IS 456-2000 clause number 26.5.2.1 equal to 0.15% for HYSD bars of the gross cross-sectional area. Distribution reinforcement. It is provided transversely across the width of the stair. It helps in distributing temperature and shrinkage stresses and also holds the concrete together during casting. Tread reinforcement. Additional bars are sometimes placed in the tread portion to resist localized bending due to concentrated foot loads. Riser reinforcement. At each bend of the sawtooth slab, extra bars are bent up into the riser portion to maintain continuity and crack control. Anchorage and lapping. Bars are properly anchored into the landing slab or beam ensuring minimum development length as per IS 456-2000 clause number 26.2.1. Now construction feature. The formwork of a sawtooth stair is more complex because of the zigzag shape. Proper shuttering supports must be given under each trade and riser angle. Cover to reinforcement is minimum 25 mm as per IS 456 table 16. Concrete grade is at least M20 for RCC as per IS 456-2000 clause number 5.3.1. Curing to be continued at least for 7 days for ordinary Portland cement or 10 days for blended cement. Now, what are the advantages of sawtooth stair? Number 1. Structural depth follows the step profile, hence economical use of concrete. Number 2. It offers higher stiffness compared to flat slab stairs. And number 3. Aesthetic appeal in exposed concrete finish buildings. And number 4. Can be designed for large spans with less deflection. Friends, this stair has some limitations also. Number 1. Shuttering and formwork are costlier and more time consuming. Number 2. It is not suitable where finishing must be perfectly flat below the stair, that is where false ceiling are to be done. And number 3. It needs accurate site supervision due to complex geometry. So friends, in conclusion, I am to say here, a hinged or sawtooth staircase is an elegant structural form where each trade and riser act integrally with a zigzag slab, efficiently transferring loads through bending and shear. It requires accurate analysis, proper reinforcement placement and precise formwork guided by IS 456 and IS 875 standards. If executed properly, it not only ensures structural safety but also provides a modern architectural look to your building. So friends, this was all about the sawtooth stair. Thank you for watching this video. If you feel this video is useful to you, please don't forget to like, share and subscribe this channel for more civil engineering knowledge videos. Meet you again very soon with such type of video. Stay tuned. Thanks.